So they're facing the same direction here. It has to be even. They're going up, means your leading coefficient has to be positive. They're going different directions. That means it had to be odd. It's going continually up, down on the left, up on the right. That's positive. Okay, so it was just asking you to decipher the graph back. Whereas I've asked you what's the end behavior going to be based on what you see. It's just asking you to then decipher what the exponent and leading coefficient would be. Different directions, odd, and it's up on the left, down on the right, that's negative. Same direction, down, that's even and negative. All right, the remainder theorem and factor theorems. So we have done long division and synthetic division. Hopefully those words don't bring total fear into your head. Long division, always everybody's favorite. And then synthetic division is the shortcut. And then what we're going to do is we're going to do this process, and then we're going to look at factoring from it, which I believe we also did that last year. We factored after it. And we're going to look at what's called the remainder theorem. The remainders actually tell us some key things about the function itself. So the first thing we're just going to do is review. We're going to do long division. If you haven't done it, it is long division just like you did in like elementary school, except they throw in, I don't know, polynomials. Okay. So.
Wait, what? Totally not changes in here.
Right? So they want us to divide this polynomial. Let me not scratch through it there. They want us to divide this polynomial by this binomial here. So what you're dividing by goes on the inside, just like you would do with long division. We have 6x cubed minus 25x squared plus 18x plus 9. That's on the inside. Make sure that if you start with 3 as your exponent, it goes 3, 2, 1, none. All right, you have to have all of them there. And then x minus 3 is going to go on the outside. Just like long division, all right? For long division with this, you actually just look at the first guy, the x, and compare it to the first guy here, the 6x cubed. And so basically, just like long division, you're saying 6x cubed divided by x is 6x squared. So what do I have to multiply x by to get 6x cubed? I have to multiply by 6 and an x squared. So that's what I'm going to multiply by. I'm going to say I'm going to multiply by 6 and x squared. All right? Because that's what I would do to get 6x cubed. And then I'm going to multiply that through to the entire binomial. So 6x squared times x is 6x cubed. And 6x squared times negative 3 then is negative 18x squared. Now, at this point in division, you are subtracting. My suggestion is you change that to adding the opposite, all right? So I'm going to change this to adding the opposite of both. If you don't, you will mess up your positives and negatives, I promise, all right? All right, so I'm going to add down now that I've changed it to adding the opposite. 6 and negative 6, those cancel. Negative 25 and positive 18 give me negative 7x squared. And then just like long division, I'm going to bring down the positive 18x. All right, positive 18x. And then I'm going to do the same exact thing. I'm going to say x times what? It gives me negative 7x squared. Well, negative 7x, right? And then I'm going to multiply through. Negative 7x times x squared is negative 7x squared. Negative 7x times negative 3 is positive 21x. And then remember, you are subtracting, so we're adding the opposite, So I'm going to add the opposite here and the opposite there. Adding the opposite because I'm subtracting. Negative and positive 7 cancel. Positive 18 and negative 21 give me negative 3x. I'm going to bring down my positive 9 plus 9. And I'm going to do this all over again.
So that's every time.
All right, so x times what is negative 3x? Well, that's negative 3. I'm going to multiply that through. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. They were nice and gave us no remainder. When I change this to adding the opposite, I have a negative and positive 3 cancels. 9 and negative 9, 0 remainder. 0 remainder. Now, what this does for us is it tells us that this guy is a factor of that polynomial. If you get a 0 as your remainder, that's what it always tells you. 27 divided by 3 is going to be 9 with a 0 remainder. Why? Because 27 is divisible by 3. 3 is a factor of 27, okay? 28, however, divided by 3 has a remainder of 1 because 28 is not divisible by 3 and 3 is not a factor of 28. So when you get a remainder of 0 in long division, whether you're just doing numbers or whether you're doing polynomials, a 0 as a remainder actually tells you something about that. It says that I could write this as x minus 3 times 6x squared minus 7x minus 3. Just like if I did this, 27, right, means that I can say 3 times 9 equals what I started with, right? I mean, that's what division means, okay? So then, because I have a quadratic, 6x squared minus 7x minus 3, I could potentially factor that more because I know how to factor a trinomial. We've been doing this the whole time. How do I factor a trinomial? Well, I'm going to break it up into two groups. Now, if you don't automatically see the two groups, you can do your across method. Remember? Do y'all remember that factoring? So 6 times 3 is 18. I'm looking for factors of 18 that add up to give me negative 7. What are factors of 18 that add up to give me negative 7? Right, so negative 9 and positive 2. So I can say, I'm just factoring this guy, 6x squared minus 9x plus 2x minus 3. So I just break up this middle term to those two that I just found. Y'all remember this? And then factor by grouping, right? What comes out of 6x squared and negative 9x? 3x, and I'm left with 2x minus 3. Can anything come out of this guy? No, so we've just put a 1 there. 2x minus 3. And then I get 2x minus 3. That's one of my factors. And 3x plus 1 is another factor. So if you don't remember your, pairing them up and figuring out what your factors are, you can factor with grouping there. 2x minus 3, 3x plus 1. And so not only did I divide it, I actually was able to continue on and actually factor it as well. It is the same as long division. You have a quotient, a dividend, and a divisor. You have a remainder. There will be times when you potentially don't have a 0 as a remainder. If you don't have a 0 as a remainder, you can't continue to factor because it's not a factor. So if you're just doing division and they want to know the answer of what is this divided by that, then if you got a remainder, so let's say this one right here, they wanted x squared plus 5x minus 4 divided by x squared plus 2. They divided it out. They got x plus 3 as their quotient, but then they had this remainder, negative 10. You treat this just like you would if you had a remainder in long division with just numbers. The remainder goes over what you were dividing by, your divisor. So your answer is x plus 3, that's what was up here, and then plus your remainder, negative 10, over your divisor, x plus 2. It actually also changed your, it also affected your domain. If this is your divisor, think about it. It would have been, this is your numerator, that's your denominator. Your domain would have this limitation. X cannot be equal to negative 2, which would actually be true the whole time because it's the divisor. All right? So if you were to happen to have one that has a remainder, it's okay. If you're finding the division, you just put your answer and then the remainder over the divisor, just like you would for regular long division. All right? Does that All right, so synthetic division, they define it right here. It's a shortcut for dividing polynomial by a linear factor in the form x minus c. I will say the best time to use this is when it does not have a leading coefficient, when your leading coefficient is just 1. It makes it the easiest, okay? If you have a leading coefficient of something other than 1, then you have to divide by a fraction with synthetic division, and then your answer you end up having to factor as well. And so it's a little bit of a mess when you have a leading coefficient. So you typically use synthetic division only when you have a leading coefficient of 1, meaning it's just the x by itself. All right. So with long division, this is what you would do. You would have your dividend here, you would have your divisor, and then your quotient would just be here. Okay, just like we do. What synthetic division does is it actually gets rid of your variables. So you put your coefficients here, 6, negative 25, 18, and 9. It comes from these guys right here. You still have to make sure that if you start with a 3, you have 3, 2, 1, and none as far as exponents go. If you're missing one, you have to put a 0 in there, okay? Normally you're dividing by x minus 3. What you're actually going to do with synthetic division is you are going to set that equal to 0. So if you are dividing by x minus 3, you're going to say, what makes this 0? Well, 3 makes it 0. So that is what you're dividing by. Positive 3. Positive 3. Okay? And then let's see the process by which we do that. That's the next part of this. The process looks a little different here. I'm going to make that larger. Okay? So the process is we set it up with our coefficients, 6, negative 25, 18, 9. We divide by whatever is making that 0, so positive 3. What we're going to do is we are going to add down and multiply up. So I'm going to say 6 plus nothing. Well, that's just 6. Easy enough. Then I'm going to say 3 times 6 is 18, and that goes here. 18 goes here. And then I'm going to add down again. You're adding this time. We're not subtracting. Negative 25 and 18 is negative 7. So then I say negative 7 times 3 is negative 21. That shoots up here. Add down, we get a negative 3. Multiply up, negative 9. Add down, 0. So now I have this row down here. 6, negative 7, negative 3, and this guy. This last guy is my remainder. So that will tell me the same things the other thing will tell me. If it's a factor, well, then that's going to be 0. If it's not 0, it's not a factor. I'm going to have to put it over the divisor. Okay? What I do is I take these, and these are my new coefficients. If I started with x cubed, this guy will be x squared. Okay? So I have 6x squared minus 7x minus 3 with a remainder of 0. All right, so let's do one. Turn to page 112. The easiest way to do this is if you don't have a fraction or you don't have a 1 in front of it. So I'm going to set this guy up. You set it up with what looks like an upside down division. They actually have it different, but I just do that. They have like a little box and then a line. It doesn't matter. And we're going to use our coefficients. Now, x to the 4th is where I'm starting. That's 2. My next one has to be x cubed. Do you see an x cubed? You do not. So because there is no x cubed, I have to put a 0 here. X squared then, that's negative 5. X, that's positive 5. And then the one without any x, so x to the 0, is negative 2. That's how I'm going to set up my top row. I'm going to divide by what then? Negative 2. So my synthetic division is actually going to be what makes this 0. That's negative 2. All right, and then I'm just going to start the process. Add down 2 plus nothing. That's easy. That is 2. All right, and then up here, I'm going to write negative 2 times 2, negative 4. And then I am going to add down 0 and negative 4. Right, and then I'm going to multiply. Negative 2 times negative 4 is 8. Then I'm going to add down negative 5 and 8. That's positive 3. Multiply negative 2 and positive 3. That's negative 6. Yep. Add down 5 and negative 6. It's negative 1, right? Negative 2 and negative 1. Yep. And then negative 2 and positive 2 is 0. All right. I started with x to the 4th. So I am going to have 2x cubed. I go 1 down from my initial degree. And then I just go down minus 4x squared plus 3x minus 1. That is that division. That would be my answer. I don't have a remainder, so I don't have to put anything over my divisor. So I am done with that one. Fractions all pretty much go away, but I want to at least show it to you. So for this one, I would set this up exactly the same way. I would have 10, that's cubed, negative 13 is squared, 5 is just x, and negative 14 here. Now, I need to set this guy equal to 0. So that's add the 3 over. So x is going to equal 3 halves. All right, so that's what I'm actually going to use here. 3 halves. This is why people typically don't use it when they have a fraction. Typically people will say long division, okay? So I'm going to add down is 10. 3 halves times 10 is going to be 30 halves, right? I mean, yes.
15.
Okay. Yeah, so it'll be, right, so 15. That's what I was saying. They're going to go away, all right? And then negative 13 plus 15 is 2. And then I have 3 halves times 2, which gives me 3. 5 and 3 give me 8. 3 halves and 8 gives me what? 12. And negative 14 and 12 give me negative 2. All right? Now, here's the deal. When you have something like this, you have to actually divide everything by 2 first or everything by 2 last. You have to divide everything by what's with your... I will say that they divided everything by 2 up front, all right, which gives you fractions like the whole time. And I prefer actually just to do it at the end. All right, so whatever's in front of this little x here is eventually going to factor out of this, all right? So when you use it with a fraction, you have to keep that in mind. What they did is they divided everything by 2 up front. So they had 5, they had 13 halves, 5 halves, and 7 here. And then they just had the fractions, and then they subtracted with fractions. I think it's easier to not subtract with fractions. I feel like you're gonna make a much easier mistake there when you subtract with fractions. But at the end, then if you did not divide at the beginning, then you have to divide at the end, okay? They divided at the beginning, I divide at the end. So I have 5, I started with cubed, that's gonna be x squared. 2 divided by 2, that's gonna give me just 1x. 8 divided by 2, that's gonna give me just 4. This represents my remainder, okay? My remainder. So my remainder is going to be a negative 1 over my divisor here, which is 2x minus 3. Okay? So on this example, our remainder was 140, okay? What that theorem is telling you is if I were to take 3 and plug it into my function, f of 3, I would get 140. So if you plug it in, that's what you will get. 4, 3 cubed plus 3, 3 squared minus 3 plus 8 is going to give me 140. So the remainder tells you 2 things now. The first thing we talked about is if it's 0, then it tells you that you have a factor, right? If you get a remainder of any sort, whether it's 0 or 140, what that is also telling you is if you took that number that you divided by and plugged it in, that is the answer you would get. You would get that answer. This says if a polynomial f of x is divided by x minus c and the remainder is r equals f of c. That's pretty straightforward. But what they're actually saying is the remainder is what happens when you plug it in. Synthetic substitution is what it's called. So what they're telling you is whatever you got as a remainder. So that is what the remainder theorem tells you. If you have a remainder, then that's the same thing as plugging it in. So you're like, why wouldn't I plug it in? Well, personally, I think synthetic division is actually easier than sometimes plugging into a huge polynomial. I can do synthetic division faster than I could plug it in and cube my 3. And I feel like there's more opportunity for error when you plug it in. People make mistakes when they plug in a negative into their calculator and they cube it or square it, whatever, okay? And so that's what it's telling you. It says, for the example they've given us, the number of tickets sold during Northside High School football season can be modeled by this function, where x is the number of games played, using the remainder theorem to find the number of tickets sold during the 12th game. Now, I could plug in 12, right? 12 cubed minus 12, 12 squared plus 48 times 12 plus 74. Or I could just use synthetic division with 12, all right? And so what they're saying is use synthetic substitution here. Do synthetic division to figure it out. So we're going to say 1, negative 12, 48, and 74. And we're going to divide that by 12 because that's the 12 games that we want. Now, when they do this and they just say, here's the number, you don't have to do the opposite. The only time you do the opposite is when they give you a binomial, right? When they just hand you the number that they want you to use for synthetic division, you don't change the sign. And so I'm going to do this all the way up. That's going to zero out. All right. They want to know to find the number of tickets sold. So my answer here is just going to be the 650. 650 tickets were sold. Because that's the same thing as if I had plugged in a 12. If I plugged in a 12, this is what I would get. I would get 650. So that's also what the remainder is telling you. It's saying, hey, you can figure out it's a factor, but you can also figure out what would happen if you plugged that number in. All right? And so, one more thing, what I've been talking about with the remainder theorem is that if you plug it in, you get your remainder, okay? Synthetic substitution is also a name for it. The factor theorem is if you get 0, then it is a factor, okay? So then there is a summary on the last page of this section. The last page of this section that tells you all the things that the remainder tells you. All right, if R is the remainder obtained from synthetic substitution, or synthetic division by f of x and x minus c, then the following statements are true. R is the value of f of c. So that's the first one, the remainder theorem, which says if this is just saying if you plug in c, which you were dividing by, the remainder is your answer. If you plug it in, the remainder is your answer. The other thing that we talked about is if you get 0, then that group is a factor of that polynomial. It's a factor. So you could potentially keep factoring. All right, let's see what else it tells us. If R is 0, not only is it a factor, but C is an x-intercept, or it's a 0. Why? Because when you plug in your C, you get y equals 0. Y equals 0 on the x-axis, right? So not only does the 0 tell you that that's a factor, the 0 also tells you an intercept. It told you your y-intercepts, at least one of them, right? Because if y is 0, it's an x-intercept, all right? And then the last one follows through to what we just talked about with the intercept. If r equals 0, x equals c is a solution to setting it equal to 0. Which means, again, you have a 0 or an x-intercept of the equation if you have a remainder of 0.